All right, so absolute value equations, we still use the method of comparing right and left limits. So we find one at a time. From the right, from the left, if they are the same, we know that the two-sided limit exists. Okay, if they're not the same, the limit doesn't exist. So where does it come from? You must know that absolute value itself is a piecewise function. What? Yes. How do you know that? From the absolute value definition. We say that the absolute value of x, okay, this one is equal to, if you remember, it is equal to, remember absolute value, the trick is absolute value always gives out an answer that is positive. So the output is always positive. X can be negative. X can be negative. But the answer that comes out of absolute should always be positive. How does it do that? It changes the sign. How? We say that our absolute value is just x if x is greater than 0. So if x is a positive number, greater than 0 means a positive number, then your absolute value just remains as x. It doesn't do anything. But absolute value takes another toll. So here we can say if x not just greater than, sorry, I could say that maybe even equal to 0. Absolute value just comes out as it is. But if x is less than 0, okay, it will now put a negative in front. So it will be negative x if x is less than 0, which means if x is a negative number. For example, if x is negative 7, your absolute value would be negative of negative 7, and that will be 7. So that's how it changes to positive. It puts a negative in front of that x. This was our x. Why? Because this x was a negative number. So the only way to change it to positive is put a negative in front of that x. I hope you're going to remember this. If you remember this, then we're going somewhere. Absolute value of x is negative x if x is less than 0. We can do more examples. Let's say that you have absolute value of x minus 4. Okay? Absolute value of x minus 4. What is this equal to? Let's try, let's do for the first one. Let's do for x greater than 0. Okay? Okay, let's do if x minus 4 rather, if x minus 4 is greater than or equal to 0. Then what will be your absolute value? Does it change the sign? No. So it's just x minus 4, right? What about if x minus 4 is less than 0? Then what is your absolute value? It is negative. It puts negative in front of whatever is in there. It is going to be negative of x minus 4. I know it's very frustrating. Sorry for that. It's negative of x minus 4, okay? If you see, if it was x minus 4, make sure that we put them in a bracket when we place the negative in front, okay? Because the negative is affecting everybody. So that's how it is, and that's how it keeps all the answers being positive. Because this inside of a bracket is going to come out as negative, but absolute will put a negative in front and change it to positive, because minus minus becomes plus. That's it with absolute value, okay? So once it does this, once it has two parts like this, that means it's a piecewise defined function. That means we could plot it. So let's go ahead and see this one. Let's see how it is. Let's see this one. Find limit as x approaches 0 of the absolute value. Find the limit as x approaches 0 of r. So in other words, our f of x is equal to this modulus of x. Let's see how we'd find the limit for this guy. We are going to put the absolute value definition. Absolute value, okay, that's the first thing you do, is equal to, then you say it is equal to x provided that x is greater than or equal to 0, provided that x is not a negative number. But if x is a negative number, your absolute will be negative x. That is if x is less than 0. Are we together? So now we can start with the first part. We can now say limit as x approaches 0 from the right, okay, of modulus of x. This is equal to the limit. We do one at a time. We'll start with from the right. From the right, okay? From the right. And what is from the right? We take x greater or equal to. So it's going to be limit of as x approaches 0 from the right of what? Of x. It's just x because we are taking x greater than or equal to 0. So our absolute value will be just x. And what is this going to be? We replace, right? It's going to be 0. We're going to put, coming from the right, we put 0 in there. We use the limit laws. Remember, limit as you approach a polynomial, you just substitute what you are approaching. You're approaching 0? Yes. So put 0 where there's x. So your answer will just be 0. Now let's go the limit as x approaches 0 from the left of modulus of x. This is going to be the limit as x approaches 0 from the left of what? Of negative x. Okay? Of negative x, which is equal to negative of 0. Okay, because you're just going to put this 0 in there. Whether we are coming from the left or from the right, it doesn't matter. We just put the 0. Okay, so we put the 0 in there, and it's negative of 0 is just 0. So you can see that the limits are the same, right? So that means it does exist. So you can say therefore, okay, you can start by saying limit as x approaches 0 from the right of modulus of x is equal to 0, and that is the same as the limit as x approaches 0 from the left, okay, of modulus of x. So therefore, you can write and say therefore, the limit as x approaches 0 of modulus of x exists, and the answer is 0. The two-sided limit exists because both one-sided exist and they are equal. In terms of the graph, here is the graph for modulus of x. You could do it step by step if you want. You could do it step by step. I can teach you step by step. Here is what it just is. I know it from the head, off head like that. So it'll be just, I need to make it neat. So it is just, here's your horizontal axis. Okay? And the graph comes down and just goes back up. Like that. Okay? Just comes down to 0 and goes back. This is the graph of modulus of x. It comes down, okay, to 0 and goes back up, flies away. This is the graph of y is equal to the modulus of x. Okay? That's the graph of y is equal to the modulus of x. And you are done. You see that it has two parts. When it is on the left here, it is going down. You see it's going down. When it is on the right, it's going up. So that is why it's a piecewise defined function. It does two different things. Okay? Let's see just a few more questions. We'll be done. Limit as x approaches 2. Sometimes they'll actually say just find from the right, like this, from the right. When it's like that, it's very easy for you. Let's go ahead and do it. I've just put it from the right. When they give you the direction to come from, it will be very easy for you. Okay? But first thing you're going to do, remember that the first thing we have to find the modulus. So we know that the modulus of x minus 2, this one, is equal to x minus 2, provided that x minus 2 is greater than or equal to 0. And it is equal to negative of x minus 2, provided that x minus 2 is less than 0. If x minus 2 is less than 0, we'll put a negative to change that answer to be positive. Okay? Whatever is inside your absolute, whatever is inside, if it is less than 0, then we'll put a negative in front. Okay? That is just what it is. So now we can say that the limit as x approaches 2 from the right of modulus of x minus 2 over x minus 2 is equal to the limit as x approaches 2 from the right of, if we are coming from the right, that means what are we? We are greater, right? That means we are greater. And let me just put it for you so that you can see it carefully and then not make a mistake. This is 2. Our x is here. That means we are going towards 2. Okay? So that means x is greater than 2. And if we take 2 to the other side, we have x minus 2 is greater than 0. So just don't worry about that. It's the same thing. Okay? So we'll be saying whenever we are coming from the right, it means we are greater than 0. So we take the part here greater than 0. And what is that? X minus 2. So it will be the limit of x minus 2 over, what is in the denominator? X minus 2. In the denominator is x minus 2 also. And these two x minus 2's, what will they do? They will cancel, right? And you get the limit as x approaches 2 from the right of 1. Now the limit of a number is the number, so your answer will be just 1, right? The limit as you come from the right for wherever you're coming from. So this is 1. Okay? If they say find the limit, and you'll be done. So here you'll be done. If they say find the limit itself, you would now have to say the limit as x approaches 2 from the left. So what did we start with? We started with the absolute value definition, people. That's what we started with, and then we ended up doing our limits. So as you come from the left for x minus 2 modulus over x minus 2, this will just be the limit as x approaches 2 from the left of what? What is on top here? What is on top? If you're coming from the left, that means you are less than 0, right? That means you're less than 0, so you say negative of x minus 2. So it's going to be negative outside the bracket, don't forget, negative of x minus 2 over x minus 2. X minus 2 cancel, remain with that negative, so it is equal to the limit as x approaches 2 from the left of negative 1, which is just negative 1. And are these limits the same? They are different. So does it exist? So you can say limit as x, limit of modulus of x minus 2, modulus, over x minus 2 itself as x approaches 2 from the right. This is not equal to the limit of x minus 2 over x minus 2 as x approaches 2 from the left. Therefore, you can write it in words. It means the limit as x approaches 2, the two-sided one, of modulus x minus 2 over x minus 2 does not exist. It means this limit does not exist. We are done. That's how you get it for this one. One last question. Show that the limit, this one is very important. Sometimes they'll ask you you can check, you see the question here, this one everywhere, in tutorials or whatever. Sometimes they can ask you, find if it exists, or sometimes they can just say, please, they say prove that prove that this limit does not exist, or show that the limit does not exist, or find the limit. So the moment you see this modular sign, you know you're going to have to do in 2 steps. So you start by modulus of x. What is this equal to? Okay, this is equal to x if, okay, or you can say it is equal to x provided that x is greater than or equal to 0. And it is equal to negative x if x is less than 0. If x is a negative number, then we put another negative in front to change it to positive. So now you can say limit as x approaches 0. From the right, you do one at a time, of modulus of x over x. This will be equal to the limit as x approaches 0 from the right of, what is it? If you're coming from the right, that means you're greater than or equal to 0. So what do you pick? X of x over x, which is equal to the limit as x approaches 0 from the right of 1, because x and x will cancel, right? You get 1. Okay, this is going to be 1. The answer will be 1. The limit of a constant is that number. So now let's go to the limit as x approaches 0 from the left of the modulus of x over x. This is going to be equal to the limit. Okay, we're just continuing on with it's going to limit as x approaches 0 from the left of what? If you're coming from the left, that means you're less than 0. What do you get? Negative x. So it will be the limit of negative x over x. And do you get negative x over x? The x's will cancel. You get the limit as x approaches 0 from the left of negative 1. And that limit is going to be negative 1. Okay, so if you're coming from the left for negative 1, your answer, the limit of any number is that number. So we'll be done. Are the two values the same? No, they are not. So you can say the limit as x approaches 0 from the right of modulus of x over x is not equal to the limit as x approaches 0 from the left for modulus of x over x. Therefore, the two-sided limit does not exist. Although the one-sided limits are existing, but the two-sided does not exist. So, that's a wrong spelling. Therefore, the limit as x approaches 0 of modulus of x over x does not exist. It does not exist. Oh, so what about if you say, sir, please draw the function for us. We want to see what it looks like. Well, you do the same thing. Okay, draw the function of modulus of x over x. So I'm going to do this. Okay. We go to our piecewise. We see where the things are happening. It is at x equal to 0. So at x equal to 0, that's where things are happening. Okay. Now, what is it? Let's see what our limit was. Our limit was 1. Okay, our limit was 1 when we were going towards 0. That is for the positive guy. That means when we were coming from the right. You see, from the right, our limit was 1. So it means in here, your limit would be 1. Your limit would be 1 here. And you were getting limit of 1. So in other words, you were getting limit of y equal to 1. Okay, that's the function. Our function was called f of x. is equal to 1. Okay, it is not no longer f of x. It is no longer f of x is equal to absolute x over x. No, you're getting limit of 1. So that means your value was actually 1 all along, and you were coming towards 1. Okay, and because you're coming from the right, it is greater than or equal to. So that means in here you're going to shade. You're going to shade this spot. I hope you're understanding. You're going to shade this spot. Okay. Or you could have just tried. You can try to put all the values and then you see what I'm talking about. So this one is easy because it's limit of a number. So that number is your function. In here we can see that our limit, it was going towards -1. So it is -1. That is where we have our starting point. Let's see if it is open. It's less than only. So that means you don't shade it. You put an open circle. And you are getting the limit of -1 itself. So that means the whole function was y equal to -1. Or f of x equal to -1. So here are your two parts of that graph. And you'll be done. Wow, come on. Put the last part. We are done. Okay, this is the x-axis. Okay, and this is this is x over x. Okay, y is equal to x over x. Or you could say y is equal to 1. Okay. This is the y equal to 1, and this is the one here, y equal to -1, or f of x is equal to -1. Okay, this is the y-axis. You are done, and that's it. Okay, thanks for watching. We'll see you in the next video where we do more types of things.